Last year, in an IoT systems class, for the final project, they basically gave us free rein to make whatever project we wanted. I had access to a Raspberry Pi and a camera that was attached to it. After some thinking, I thought back to a controversy that happened in 2021 where chess player Hans Niemann was accused of cheating by Magnus Carlsen after he beat him in a chess tournament. Carlsen said that the only way that Niemann could have won was by using a vibrating cheating device. So I'm not very good at chess, so I don't think I could make a very good chess algorithm, but I do know that Blackjack is pretty deterministic for when you hit stand, split, or double. So what my thought was is that I could make a device where I basically put the camera over the cards and then it reads the hand, and then it'll tell you what move to do, what the most ideal move to do is on the table, so you can make the most money. So basically a blackjack cheating device. So to relay that information back to the user, I also had to get a vibrating device, my phone. So for the project, I built that device, and I'd like to show you how it works and how the code works. I've since disassembled that device, so all the footage is old, but it should be fine still. All right, so anyway, enjoy. So the real heart of this project is the YOLO V8 model that's hosted on the RoboFlow API right here. So basically how this is used is a picture is taken on the Raspberry Pi, and then I send that off to this API, and it returns back the predictions and locations wherever those predictions are made. So as you can see here, it predicted a 7 of spades here, and a 7 of spades here on the other side of the card, and then an ace of hearts, and then an ace of spades. For this project, I created a Python script on the Raspberry Pi as a server, and I used Android Studio to use the Android phone as a client. So first, let's go through the client software. So the user interface of this app is actually super simple. For one, we have a box up here to enter in the Pi's IP address so that you can use WebSockets to communicate between the two devices. We also have a button right here, so when you click on it, the Pi knows to read the board and send you back what the ideal move is. We also have a little output box right here that tells you which move you have to do. Ideally, though, you won't use this, and instead we'll be just relying on the vibrations that it sends back. If the phone vibrates once, that means that you should hit. If it vibrates twice, that means you should double. And if it vibrates thrice, that means you should stay. We don't have any split functionality, though, because it gets super complicated with multiple splits and reading where the board is. So I just didn't account for splits in this program so far. So the client code is pretty simple. Basically, what you have is on click, you will create a socket, and you'll basically create an input and output data stream so you can read and write from the Raspberry Pi, and then you send the Raspberry Pi to get the move. So this will initiate the Raspberry Pi to take a picture, send the thing to get the predictions, and then send back what move you should do. Then eventually you'll get the reply, and then this vibration service will basically just create the pattern that you need to do to vibrate. So that'll be 1, 2, or 3 times, and then it'll vibrate the phone to indicate which move you have to do. We'll also set the output right here to the amount of vibrations you have. So that'll be 1, 2, or 3. So yeah, this is very simple code for the client to just, send get move whenever this button is clicked, and then just receive whatever the Raspberry Pi sends back. So the server code is a little bit more involved. So first we just have to do, just stuff to set up the socket, like setting the ports, and then we also have to set up the Pi camera so that it can take pictures. In the main loop of the server, we basically just wait for the client to connect and then just receive whatever data it takes, and then or it sends to us. Then we run this getMexMove function that I'll explain later that basically does the bulk of the work and replies back with either 1, 2, or 3 for hit, double, or stay. And then we will encode that using this JPY encode because we have a Python server and a Java client, so we need to encode it in a way that they'll both understand. And then we can just send that message off to the client, and then just continue doing that until the user breaks out of the loop. Now I'll explain the getNextMove function. So for the getNextMove function, we start by capturing an image from the Pi camera and saving it. And then what we do is we send that picture to the RoboFlow API. So that will basically interpret the image and tell which cards are in the image and where. Then what we do is we can basically split the predictions between the dealer cards and the player cards by splitting it between if it's in the top half or the bottom half of the image. So this gives us which cards the player has and which cards the dealer has. We then can calculate the values that each player has by using this translation dictionary up here. And we can also handle the cases where the hand is over 21, but you have an ace in the hand, so the 11 turns to a 1. And that will just happen here. Then after that, we run this function next move. So if your current value is less than 8, you're always going to want to hit. And if it's greater than 17, or greater than or equal to 17, then you're always going to want to stay. But anywhere in the middle, it depends on what the dealer has and what you have. So to determine if you should hit, double, or stay, we use this get move table right here, which will the dealer hand is the rows. So if it's a 2, it's here, 3, 4, 5, 6, 7, 8, 9, 10. Then if it's and then the columns are going to be the player value. So then what we do is we add 1 to this next move, whatever next move returns, because we're going to want to vibrate once for hit, twice for double, and thrice for staying, because you can't vibrate the phone 0 times. So this just makes it so that the Android can actually vibrate in a way that makes sense. So this is what the return value of this getNextMove function that we saw right here is. All right, so this is our project working. So you can see right here, I'm signed in on VNC. I have the mobile app right here booted up on the Android phone. And we have the Raspberry Pi with the Pi camera connected up to this little tripod right here. And we have the cards, the hand below. So this right here is the dealer's cards, and this is the player cards. So real quick right here, I'm gonna boot up the server by just running the Python file. And as you can see, it boots up the camera, and then it'll say waiting for connection, and that means that the server's all booted up and it's waiting to be connected from the phone. So right here, I have the IP address of the local IP of the Raspberry Pi right here, so I can connect it, and then I'll press get move. So this then will connect here, and it will interpret the thing right here. So I don't know if you can hear through the video, but it just vibrated once, and you can see the output right here was 1. And you can also see all of the details of what it just said. So it shows that it found that the player has a king of diamonds and a 5 of hearts, and you can see that's correct. And you can see that it says the dealer has a 7 of diamonds, which is also correct. And then it computes what score you have, 15 and 7. And then it will basically just say, okay, using those cards, that means that it wants you to hit, which is 1. 1 is hit, 2 is double to bet, and then 3 is to stay. So on this hand, it says you should hit. All right, now let's say after we hit, we got an ace. So an ace can be either 11 or it can be 1. So if it's 11, you can see that this is over because this is 21 plus 5, which is 26. So this one has to be a 1 then, which would be 16. So just showing that the program can accept that, when I press get move, you can hear it vibrated once again. And you can see right here it says it has an ace of spades, it has a king of diamonds, and a 5 of hearts. And then you can see that now it's computing that this hand is worth 16 and not 26. So you can see that it automatically assigned this to a value of 1. So again, it said to hit, so let's do another hit, right? So now we're at, this was 16, and then plus 3 is 19, right? So 19, you would usually stay, which would be 3 vibrations, right? So you can see here, the server's still running. Let's press get move again. And you can see that it vibrated 3 times, and you can see there's a 3 right there, showing that we want to stay now. And you can see right here that it added the 3 of diamonds, which is what we have right here, to the player hand. It computed 19, and then it sent back that we should stay. So yeah, that's the project. Thank you.